lithium, a tiny element with a massive impact. From the battery inside your phone to the power cells in electric cars and even spacecraft, lithium has quietly become one of the most valuable materials in the modern world. But what exactly is lithium? Why is it so special? And how did this small, silvery metal come to hold such importance in our everyday lives? Let's explore the full story of lithium, from its discovery and properties to its uses, challenges, and bright future. Let's have an introduction to lithium. Lithium is a chemical element with the symbol Li and the atomic number 3. It's part of the alkali metals, a group of elements in the first column of the periodic table that includes sodium and potassium. Among all metals, lithium is the lightest, so light that it can float on water, though it reacts quickly with it. At room temperature, lithium appears as a soft, silvery white metal. If you cut it with a knife, it shines brightly for a moment, but soon dulls as it reacts with oxygen and moisture from the air. This reactivity makes lithium a very active metal, and it must be stored carefully, usually under oil, to prevent it from reacting with air or water. Despite its simplicity, lithium plays an essential role in many areas of modern science and technology. Its combination of lightweight, high energy density, and strong reactivity make it ideal for storing energy, creating powerful batteries, and forming lightweight alloys. Discovery and naming of lithium. The discovery of lithium dates back to 1817, when Swedish chemist Johann August Arfvedson was analyzing a mineral called petalite, found on the island of Uto in Sweden. During his analysis, Arfvedson found that the mineral contained a previously unknown element, one that behaved similarly to sodium and potassium but was lighter. He named this new element lithium, derived from the Greek word lithos, meaning stone, because it was found in minerals rather than in biological sources, unlike many other elements known at the time. Although Arfvedson discovered lithium's presence, he couldn't isolate it as a pure metal. That achievement came a few years later, in 1821, when British chemists William Brandes and Sir Humphrey Davy isolated pure lithium metal using electrolysis, passing an electric current through lithium oxide to separate the metal from its compound. From then on, lithium became known as the lightest solid element, marking the beginning of its journey from a simple mineral to one of the most valuable industrial materials of our era. Atomic structure of lithium. Lithium's atomic structure is what gives it its remarkable properties. It has 3 protons, 3 electrons, and typically 4 neutrons in its most common isotope. Its electron configuration is 1s2 2s1, meaning there's a single electron in its outermost shell. That one electron is loosely held, and lithium readily gives it up during chemical reactions, forming Li+ ions. This makes lithium highly reactive and a good conductor of electricity. Because of this single outer electron, lithium belongs to the alkali metal group, elements known for their strong reactivity and ability to form stable ionic compounds. In short, lithium's atomic structure is simple but powerful, a tiny atom with a big energy potential. Physical and chemical properties. Lithium is unique in both its physical and chemical behavior. Let's look at some of its most important properties. Symbol, Li atomic, number, 3 atomic mass, 6.94 U state, at room temperature, solid density, 0.53 g/cm3, the lightest of all metals. Melting point, 180.5 degree. Boiling point, 1342 degree, color, silvery white. Reactivity, very high, especially with water and oxygen. When lithium comes into contact with water, it reacts to form lithium hydroxide, LiOH, and hydrogen gas, H2, 2Li plus 2 H2O, 2 LiOH plus H2, 2Li plus 2 H2O, 2 LiOH plus H2. This reaction produces heat and bubbles of hydrogen gas, though it's less violent than reactions involving sodium or potassium. Lithium also reacts with oxygen in the air, forming lithium oxide, Li2O, which gives its surface a dull gray color. Lithium is also an excellent conductor of electricity and heat, which is why it's perfect for energy applications like batteries. Natural occurrence of lithium. Lithium doesn't exist freely in nature because it reacts too easily with other elements. Instead, it's found in various minerals and brine sources. Some of the main lithium-bearing minerals include spodumene, Li-Al-Si2O6, lepidolite, a lithium-rich mica, petalite, Li-Al-Si4O10. In addition to minerals, lithium is also found dissolved in saltwater brines, which are underground pools of salty water rich in lithium compounds. When this water is brought to the surface and allowed to evaporate, it leaves behind concentrated lithium salts that can be processed to extract pure lithium. The largest lithium reserves are located in Chile, Bolivia, Argentina, Australia, China. Together, Chile, Bolivia, and Argentina are known as the Lithium Triangle, an area that contains over half of the world's known lithium resources. Isotopes of lithium. Lithium has two naturally occurring isotopes: lithium-6, Li-6, lithium-7, Li-7. Li-7 is more common, making up about 92.5% of all lithium found on Earth, while Li-6 accounts for around 7.5%. These isotopes have applications beyond batteries, for instance in nuclear reactors and fusion research, where lithium is used to produce tritium, a fuel for fusion energy. Major uses of lithium. Lithium may be small, but its uses are enormous and diverse. It has applications in energy, industry, medicine, and technology. 1. Lithium-ion batteries. This is the most famous and important use of lithium today. Lithium-ion batteries are found in nearly every portable electronic device: smartphones, laptops, tablets, and electric vehicles. These batteries work by moving lithium ions between two electrodes, the anode and cathode, through a liquid or solid electrolyte. This back-and-forth movement stores and releases energy efficiently. Because lithium is lightweight and can store a lot of energy in a small volume, it's ideal for powering modern electronics. Lithium-ion batteries have also become critical for renewable energy storage systems, allowing solar and wind power to be stored for later use. 2. Aerospace and lightweight alloys. Lithium is used to create strong, lightweight alloys with aluminum and magnesium. These alloys are used in aircraft, spacecraft, and military equipment, where reducing weight is crucial for performance and fuel efficiency. 3. Medicine. Lithium isn't just for machines, it also helps the human mind. Certain lithium compounds, such as lithium carbonate and lithium citrate, are widely used to treat bipolar disorder and depression. These compounds help stabilize mood swings and have been a cornerstone of psychiatric medicine since the mid-20th century. 4. Lithium compounds, especially lithium oxide, are used to make heat-resistant glass and ceramics. They prevent glass from expanding or cracking under high temperatures, making them ideal for cookware, oven doors, and smartphone screens. 5. Lubricants and greases. Lithium stearate is a compound used to produce high-performance lubricants. These greases can withstand high temperatures and are used in automotive engines, aircraft, and heavy machinery. 6. Air purification. Lithium compounds like lithium hydroxide and lithium peroxide can absorb carbon dioxide from the air. This property makes them useful in submarines and spacecraft, where maintaining breathable air is essential. 8. Reactivity and storage. Because lithium reacts quickly with water and air, it must be stored carefully. It's typically kept under mineral oil or kerosene to prevent contact with oxygen and moisture. When lithium burns, it produces a bright crimson flame, which is why it's also used in fireworks and flares. Compared to other alkali metals, lithium's reactivity is less violent, but it still poses fire risks if not handled properly, especially in battery form, where damaged cells can cause overheating or even explosions. 9. Environmental and economic impact. Lithium has become one of the most sought-after elements in the 21st century due to the growth of electric vehicles and renewable energy storage. However, Lithium extraction comes with environmental challenges. Mining lithium from brine pools requires huge amounts of water, especially in arid regions like Chile's Atacama Desert. This can lead to water shortages, land degradation, and ecological damage. To make lithium production more sustainable, scientists are developing battery recycling technologies, new extraction methods that use less water, alternative battery chemistries, like sodium-ion, to reduce demand. Despite these challenges, lithium remains essential for the global shift toward cleaner energy. 10. The role of lithium in renewable energy. Lithium is at the center of the green energy revolution. As countries move away from fossil fuels, the demand for lithium-powered storage systems continues to rise. Electric vehicles, solar power banks, and wind energy storage all depend on lithium-ion batteries to keep electricity available when it's needed most. This has led many to call lithium white gold, because it's now one of the most valuable natural resources on Earth. Tech companies and governments are investing heavily in lithium production, battery recycling, and research into more efficient energy storage technologies. The future of clean, renewable energy depends heavily on this tiny metal. 11. Fun and fascinating facts about lithium. Lithium is so light that a block of it can float on water. It burns with a bright red flame used in fireworks and signal flares. It was one of the first 3 elements formed after the Big Bang, along with hydrogen and helium. Lithium is found in stars, and even in trace amounts in the human body. It's used in thermonuclear fusion research as a potential energy source for the future. Despite being a metal, it's so soft you can cut it with a kitchen knife. 12. The future of lithium. The future of lithium is both bright and challenging. As the world transitions toward renewable energy, the need for lithium is expected to quadruple in the coming decades. Electric vehicle companies like Tesla, BYD, and others rely heavily on lithium-ion batteries, and governments around the world are racing to secure lithium supplies. At the same time, scientists are exploring alternatives like solid-state batteries and sodium-ion batteries that may one day reduce our reliance on lithium. There's also growing interest in recycling old batteries to recover lithium and other valuable materials instead of mining new ones. So while lithium remains essential today, the future will likely bring smarter, cleaner, and more efficient ways to use it. Conclusion: lithium is truly a modern miracle, the smallest metal with the biggest impact. From powering your smartphone to driving the future of electric vehicles and sustainable energy, lithium stands at the heart of modern progress. Its discovery over 200 years ago opened the door to a world powered by clean, portable energy. But with great power comes great responsibility. As we depend more on lithium, we must also find ways to extract, recycle, and use it sustainably. In many ways, lithium is a symbol of our time, light, powerful, and full of potential. It shows how even the smallest elements of nature can transform human civilization, one atom at a time.